Now we'll go over to answer some of the audience questions. First off from the app, and then also from the audience in the room here. We have a host, which is Alice from Rockstar Games, and then we'll welcome back Alexandra White from Google to the stage. Give them a hand.
Good to see you again. Hello.
Good, good.
Yeah.
Who's that? So the first question I have is for Alexandra. And it is, how do we ensure that functionality changes are reflected in the documentation that's being updated?
That, I think, is the #1 question I get, right? Like, the first step is write docs, and then all of a sudden the project or the product changes, and you're like, well, these docs are out of date. Oh no, what do we do? How do we keep this up? Mm-hmm. I feel like there's two things. It depends on how much time you have. First, prioritizing the things that don't change, prioritizing explaining concepts, explaining language that you use that's very common, again, glossary items, which I mentioned in the talk. And there is a controversial idea of dating the documentation. Like, in some ways, you're exposing yourself if you're not updating it, as this isn't updated. But also, you're giving people a warning of, this might not be exactly what you expected. Yes. And prioritizing. Like, the most important stuff, make sure that's up to date.
The next person asks, is there a case for writing unit tests as a form of documentation?
Totally. Yes. Absolutely. Nothing else to say. Yes.
How do we deal with documentation of software which might change frequently? I think you touched upon this in your first response.
Yes, I think so.
And then we have, how do we avoid over-documenting my software?
It's a hard thing. I don't really think that there is over-documenting, which might be, again, controversial to say. But you'll know if people don't use it, like if you use analytics and see, oh, these documents aren't being read, you don't need to maintain it, and you can always deprecate. But it's much harder to create something that doesn't exist than it is to take something away.
Mm-hmm. And then, do you have any final words to explain how to balance between complete and easily maintainable documentation?
That's a great question.
It's a balance.
Yeah, it's a constant balance, and it's how many resources and how much support you have for documentation. If you have support, if there's manager support, if there's time spent on it, then go in depth. But it's easy to lose things like screenshots, which are often the most out of date. Visual representations are often the most out of date. Make sure that the things that are definitely going to hang around are very completely documented. And for newer features, start small. Start with less and easy to maintain, and then you can add more.
I have some additional questions about the What's Next in C# talk. Mm-hmm. So the first question reads, with raw string literals, are tabs treated the same as spaces?
Oh, tabs and spaces. I can't remember. I can't remember exactly what we do with the tabs. Yeah. Why don't you try that? Whoever asked that, get the preview and try it out. I've been asked once before, recently, and I should find out the answer. I'm sure what we do is entirely sensible.
The next question reads, what if I want a quote at the start and the end of my string literal?
If you want a quote at the start and the end, you can. Yeah, so the problem is you want quotes in the content, but in a single line literal, but you also want delimiting quotes. Like, how can you tell where one starts and one stops? And the answer is you can't tell. So what you have to do is to create a one-line, multi-line literal. And that's another reason why the multi-line ones require their starting and closing quotes on separate lines from the content. So yes, you have to waste a few extra lines on it, but you can express it in that case. You know, quote, 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 next line, quote, blah, 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 quote, next line, quote, quote, quote. And vice versa.
The next question reads, how is T additive identity different from the default T?
How is T.additive identity different from default of T? So that's a great question. So we do have there's sort of one abstraction we already have, one static abstraction we have over type parameters, and that is default of T. That's been in the language since we added generics. So why can't you just use that instead of 0? Well, not all numeric types may have the default value be the representation of 0. Let's say that for some reason you used classes instead of structs to represent numbers. The default value of a class is null, and the representation of 0 is probably an object that exists and has some content, probably a lot of 0 inside, you know, but default of T would do the wrong thing. So it is something that you need to abstract over and make part of the contract.
Okay. Is it possible to use the exclamation point or bang or however you want to call it instead of the required keyword?
Is it possible to use an exclamation mark instead of a required keyword? Well, kinda. I assume by the exclamation mark, what is referred to is sort of the null forgiving operator that you can, on an expression that's supposed to not be null, you know, the compiler might not be able to tell that it's not null, especially if it's null, and it'll warn about it, but you can put a bang to shut up the compiler and say, I know better. I know that this null is actually not null, or you know that it's fine to put it there because it's not going to be observed or whatever, and that's sometimes useful. So what you could do today is to say, you know, property equals null bang. And what you're essentially saying is, I'm going to stick null in there anyway, and now I have a place to put the bang, which I don't if I don't initialize it. But what you have now is an unsafe situation, essentially, where nobody's making anyone put a value in there, and it's null. So the whole thing that the compiler was warning you about is still a problem. It's just that you chose to shut it up. What you really want to do is to remove the problem, and required does that.
That makes sense. This comes from someone who's a fan of functional programming.
Okay.
And it says,
I think I met you yesterday then.
how much more functional do you imagine C# can become?
How much more functional could C# become? I think still quite a bit, but C# will never become a functional language. If you want that functional feel, go and use F#. It's excellent, and there's something about the feel of the language. I may be eating my words in 15 years, but who can?
We'll see.
I'll probably retire by then. It's fine. But I think there are some fundamental things that we are not likely to do. We're not likely to have currying easily supported. You can do it, but it's kind of awkward. We're not likely to. We will never be able to do the same amount of type inference that a functional language can do, because typically a functional language, even F#, does not have implicit subtyping. Like, if I have class student, it's not automatically a person. You have to coerce it. And when you have types that locked down, then you can do a lot more type inference. Because you know it's not just maybe something like this, it's this. So the amount of type inference is never going to be the same, and therefore the amount of terseness is never going to be the same. A couple of other things. So we steal as much as we can from functional programming because it has solutions to really important problems. For instance, the pattern matching solves the problem that in object-oriented programming, you always have to put the function, if you have the functionality that depends on the shape of things and the type of things, you always have to put it with the type in a virtual method. But nowadays, the data is out there, and I'm writing code over the data, and the structure of the data, the declaration of the type, may not be, I want to use a standard one that's already there. It doesn't know about my scenarios. So I want shape-dependent behavior outside of the types and outside of virtual methods. And pattern matching can give you that. That's how functional languages do it. They were right about that in a way. They have a good alternative. And you can always put it in an extension method, and then you can still say dot and do the thing, but it's implemented with a pattern match instead of a virtual method.
The next question we have says, do string literals remain leading and trailing line breaks?
Could you say that again?
Do string literals remain leading and trailing line breaks?
Oh, do they retain, do they keep leading and trailing line breaks in the raw string literals? I think that's the question. They don't, if you mean the line break between the open quotes and the first line of content, that line break is not part of the content. It's only when you get to the next line that content starts. And at the end of the last line before the line break, before the end quote, that line break is also not included. So that's how you were able to get single line strings even with a multi-line literal.
Do you envision C# will be so feature complete that we will not need any more new features?
Do I envision that?
So whole.
We've thought that a couple of times, actually. I remember when I was very new, I got to sit next to Anders when we were being interviewed at a conference. And somebody asked him, how many more versions will there be of C#? And this was when we were touting C#3 and Link and all that stuff. And he said, I think it has 1 or 2 more good versions in it after that. Then we're probably done. That's how we felt. But then the world changes. There were no smartphones. There was no cloud. Back then, it was like, as a Windows app development language, this one's pretty darn near there. But then you realize you have to be relevant in new scenarios. And there are other languages finding better ways of doing things. And that sounded really... Did you get that in your ear? So now I don't think I believe that anymore. I think the thing that is going to make us stop developing C# is either like some big paradigm shift that we can't, that is so like right turn that we can't embrace it in C#. It needs a new style of language. Let's say we were all doing quantum computing. You can't do that in C#. You can never do it in C# because quantum computing requires there to be things you cannot do in the language. And those are things that you can already do in C#. So, you know, that kind of thing.
Makes sense.
Or all the customers go away. That would also do it.
And the last question we have here is, in pattern matching with the recursion example, so the recursion example from earlier, what impact does it have on memory?
What impact does it have on memory? The recursive example. So yeah, you got to be aware of the costs incurred by the slicing, as we talked about. But then there's a cost incurred by the recursion itself, which is the stack grows whenever you do a recursive call. Some functional languages pride themselves on dealing with tail recursion, and IL, the common format that we compile down to, does have a tail recursion call that we don't actually use from C#. Because we feel that it's fairly limited when you can use it. And what tail recursion does is that if the call is the last thing, recursive call is the last thing you do, it'll remove your current stack frame before putting the new one in, because it doesn't need to remain. There's nothing left to do on that one. And then it keeps your stack height constant. But first of all, we don't think that's going to be very common in C#. We may have to look at it again. But the other one is, recursion is really not a good way of doing iteration, right? If you want to do iteration, just do iteration. I mean, imperative programming is there for a reason. And by iteration, I mean like while true, do, you know, infinite loop. Don't do that with recursion. Why would you do that with recursion? The thing recursion is good for is traversing a recursive data structure. And recursive data structures just aren't arbitrarily big, you know, they have to fit in memory. And so likely you're fine chasing those with recursion and your stack, you know, okay, allocate twice as much stack if you need, but you're not likely to go forever. Unless it's cyclic and you didn't know, in which case you have another problem. Okay?
That's good. Should we take any questions from the floor? Good.
Hello? Okay, great. I think we'll stop it here. It's time for lunch. But thank you so much for brilliant talks, Mats and Alexandra, and thank you for hosting Alice. Let's all give them a round of applause.